Hello everyone, welcome back to my channel. For today's video, we will graph and solve linear inequalities in two variables. But before that, please subscribe and like this video. Thank you! So first, let us define what linear inequality is. It is similar to a linear equation, but the equal sign is replaced with an inequality symbol. A solution of linear inequality is any ordered pair that makes the inequality true. And then, a linear inequality describes a half region of the coordinate plane. All points in the region are solutions of the linear inequality, and the boundary line of the region is the graph of the related equation. Now, I want you to look at this illustration. So, according to this illustration, when the inequality uses less than or equal to and greater than or equal to, we will use solid line. So what does it mean? It means that all points fall on the boundary line are solutions of the inequality. And then, when the inequality is written as less than or greater than, we will use dashed line. Dashed line means that all points fall on the boundary line are not part of the solution set. Now, let us have this example. Graph the solution of the linear inequality y is less than or equal to 2x minus 3. So the first step is to write the inequality in slope-intercept form. Now, if you see that the given inequality is already written in slope-intercept form, y is less than or equal to 2x minus 3, then let us go to step number 2. And for step number 2, we will identify the y-intercept first. So if this is our y equals mx plus b, where b is your y-intercept, therefore, your y-intercept or b is negative 3. So we will plot the y-intercept b, and remember, it's always on y-axis, and that will be your first point. So let us plot. This is your y-axis, and negative 3 is here. Negative 3 is on y-axis. Next, from the y-intercept, use the slope, rise over run to plot the second point. In this inequality, the slope is 2, so that will be 2 over 1. Rise is either go up or down, depends on the sign. Since true is positive, so we will go up 2 units, and your run is either go right or left, depending on the sign. Since this is a positive number, therefore we will go right 1 unit. So, says here, from the y-intercept, which is negative 3, let us rise 2 units from here. Let me change the color so that you could see that we go up 2 units. So from here, go up 2 units, 1 and 2. Then, go right 1 unit, and then we have that one, and this is our second point. So since we plotted those points already, then let us connect the points with the correct boundary line. So the boundary line that we are supposed to use is what? For this, since we use less than or equal to, we will use solid line. So let us connect using solid line. Alright, so let us connect this one all the way up and down. Alright, so the question now is, where would be the shaded region? Is it on this side? So let's call it region 1. And this is region 2, the other half plane. So you know that this is less than. So what is the region less than or equal to? So for you to know that, we have to follow this step. Check y is less than or equal to 2x minus 3. For us to know that, we will test the point using 0, 0 for x and y because it's not on the boundary line. So let us plug in 0 to y. This is 2. And your x is 0, negative 3. So this will be 0. 2 times 0 is 0, negative 3. Okay? Now, is 0 less than or equal to negative 3? Is this statement true or false? Remember that 0 is bigger or greater than negative 3. So therefore, the test point 0, 0 made this inequality false. So the shaded region will be on region 2. So what does it mean? It means that a false statement means that half of the plane containing 0 should not be shaded. So therefore, since 0, 0 is here and it made the inequality false, we will not shade wherever 0 is or the plane containing 0, 0. So therefore, the shaded region will be on this half plane. So what does it mean? It means that from the points on the line going to this region are the solutions, or you can find all the ordered pairs that will make this inequality true. Alright? So this is how you graph linear inequality. Let's have the second example. Graph the solutions of the linear inequality 5x plus 2y greater than negative 8. Remember that your first step is to write the inequality in y equals mx plus b form. So let us solve for y. 5x plus 2y greater than negative 8. So solve for y. This is 2y. Subtract 5x on both sides. So this will be minus 5x and copy minus x. Then divide both sides by 2. 2 divided by 2 is 1. So we have y greater than. So this will be negative 5 over 2x minus negative 8 divided by 2 is 4. And then step number 2 is to plot the points, but let us identify the y-intercept and the slope first because this will be our points on the line. So your y-intercept is negative 4 and the slope is negative 5 over 2. Remember, this is rise over run. 5 is negative, so you should go down 5 units, and 2 is positive, so your run is 2 units to the right. So let us first plot negative 4. Again, it must always be on y-axis. So negative 4 is here, and then negative 5 is your rise. We should go down 5 units. So let us count 1, 2, 3, 4, and 5. Then 2 units to the right, 1 and 2. Then your point will be here. So if you want to check, let's go up 5 units. 1, 2, 3, 4, 5. And then 1, 2. So that will be the other point. Then 1, 2, 3, 4, 5. 1, 2. And that is the other point on the line. 1, 2, 3, 4, 5. 1 and 2. And that's it. Okay? But it's okay if you only connect these 2 points. And for step number 3, we have to decide which line we're supposed to use. So since we use greater than, we have to connect these points using dashed line, meaning all points found on the line are not part of the solution set. And step number 4, which is your last step, we have to test the point. Test the point using 0, 0. So, to test the point, we will simply plug in 0, 0 to this, or if you want to use this, it's fine. But let us use the original equation, 5x plus 2y is greater than negative 8. So let us multiply. This is 0 plus 2 times 0 is greater than negative 8. So of course, 0 plus 0 is 0 greater than negative 8. Is 0 greater than negative 8? Is it true or false? Then the answer is true. So therefore, where will be the shaded area? Okay, so since 0, 0, which is here, made the inequality true, therefore, the area or the plane containing 0, 0 will be shaded. So let us shade this area starting from the dashed line, but please do not forget that points, or all points rather, found on the dashed line are not part of the solution set. But any points found on this area will make this inequality true. And lastly, graph the solutions of the linear inequality 4x minus y plus 2 less than or equal to 0. First step is to write this equation in slope-intercept form. Minus 4x on both sides, minus 2 on both sides, plus 0, so we will not write that down because that is 0. Now, to find y, we will divide both sides by negative 1. Remember, when you divide or multiply inequality by a negative number, do not forget to flip the inequality sign. So therefore, negative y divided by negative 1 is y. Okay? Remember that we divided it, so therefore, you have to flip the sign. Less than or equal to becomes greater than or equal to. Then, negative 4 divided by negative 1 is positive 4x. Negative 2 divided by negative 1 is positive 2. After that, let us identify the y-intercept and the slope. the y-intercept is positive 2, and the slope is 4, or 4 over 1. So, let us plot our first point, which is the y-intercept 2, and it's always on y-axis. Your slope, rise over run, is 4. Your rise is 4 units up, and your run is 1 unit right. So let us go 1, 2, 3, and then 4. Your run is 1 unit to the right, so therefore, this is your second point. And after you plot those points, alright, we have to decide which line are we supposed to use. So since we use less than or equal to, then solid line will be your boundary line. So let us count. 1, 2, 3, 4, and then 1. Here, 1, 2, 3, 4, and 1. 1, 2, 3, 4, and 1. 1, 2, 3, 4, and then 1. So, let us connect these points using solid line. And the last step is to check the shaded area using 0, 0, because 0, 0 is not on the line. So if you want to use y is greater than 4x plus 2, that is all up to you, or the original equation. So let us check. 4x minus y plus 2 is less than or equal to 0. Remember that we are just testing the point using 0, 0 because it's not on the line. So this will be 4 times 0 minus 0 plus 2 is less than or equal to 0. Then we have 2 is less than or equal to 0. Is this statement true or false? And your answer is false. So, 0, 0 made the inequality false. Therefore, we will not shade the area containing 0, 0, but the opposite side. So, meaning that all points found on this area, shaded region, are the solutions or can make the inequality true, including all points on the line. So that's it. If you have any question, please comment down below. And if you want to have another video tutorial in math, just comment down below, and when I got it, I will respond to you as soon as possible. So, please continue to support me by subscribing to my channel. If you want to share this and find this informative, thank you very much and have a good one. Keep safe and God bless you all.